Okay, let's get started. Can everyone hear me? All right, excellent. We're just going to jump straight into it, assuming I don't rush too much. There's quite a bit to cover, so hopefully the demo gods will be with me today. First time presenting at Mac Admins and attending, so that's kind of cool. You guys probably looked at the schedule and probably were expecting to hear a presentation about journey from bugs to secure tokens. Well, unfortunately, we're not going to be talking about that today. We're actually going to be looking at what Apple left out about secure tokens, which some of you probably guessed the reason why that changed. So, who am I? My name is Simon. I work for a contractor called Empower. I work at NIH. During the day, I'm a Macintosh SME, Jamf admin, insert title of the day here. Best ways to reach me, find me on Twitter, LinkedIn, Mac admin Slack. I confess I don't spend a whole lot of time on that. And then GitHub. Couple customary disclaimers. The views presented here are my own and not the views of my employer. A little bit of a TLDR. So obviously, I don't actually have Apple source code, so these are kind of my opinions. And I'm unfortunately not going to be showing you disassemblies of OS X today. Most commercial software has terms of use that says you can use but do not look. So if any of you were hoping for disassemblies, that's unfortunately not going to be happening today. So, disaster strikes. My presentation's doomed. Got the offending link here. Some of you probably recognize this link. So Apple released some documentation. Unfortunately, is about secure tokens. I guess it's kind of a risk you take when you submit a presentation about an undocumented feature. Apple might document it. I figured I was pretty safe given that they didn't bother to document it for about a year, but guess not so much. So this is the piece that we care about, and of that, really all we care about is the first paragraph, because the rest of it's really just about how to manage a secure token. You should use FDE setup, the usual kind of drill, a lot of which I think most of us already had figured out after having to fight with secure token for well on a year now. So if we actually look at that first paragraph, all we really care about is kind of that last sentence there. So Apple tells us that specifically a secure token is a wrapped version of the key encryption key, the KEK, protected by a user's password. Okay, that's fun. So, well, Apple's right. If you actually disassemble the binaries, you look at the code, it kind of holds up. That's part of what secure token does. Well, fantastic. Presentation over. Thanks for listening. Just kidding. Fortunately, for my presentation here, there's a bit more to this story. So let's look at the pieces, specifically pieces that Apple's kind of left out on their documentation. So secure access token.plist. How many of you have seen this, played with it, used it? Anybody? Show of hands. Okay, got one person. Fantastic. Recovery key handling. So this returns. And password sync. Again, all of us probably remember the good old days of HFS and having to always remove and re-add users because the password won't sync when you had AD accounts. So let's take a look at these pieces. But first, let's look at a bug to confirm Apple's documentation. So this particular bug I found because I was assisting a colleague with a laptop that he was having trouble getting set up. And I was remote, my colleague was with the user. One of the things I noticed was the user did not have a secure token, so I went ahead and did the usual sysadmin CTL interactive secure token on to try to re-enable the token, punched in the admin creds, and in handing the computer over to my colleague, inadvertently hit the return key on the laptop. Most people would expect the OS should complain at you and say, sorry, no password, this isn't valid. Surprisingly enough, though, just hitting enter gives us a process successful. Secure token is now enabled, which is always fun. Of course, obviously, this must be a glitch. User never supplied a password. That shouldn't be possible. So just out of curiosity's sake, go ahead and reboot the computer, just see what happens. User tried their password. Obviously, it doesn't work. Bit of a bonus, though, no password works, which is always fun. So kind of a time saver, right? no password at file vault. Of course, as with many of these things, it does get worse, lots worse. So your encryption password's blank. That's pretty bad. Your password policy. How many of you guys use password policy to manage your user's password? Show of hands. Okay, few of you do. Okay, well, unfortunately, that doesn't work. With this, your password policy is completely ignored. You can also adjust the password for any user, kind of like you're in a recovery partition. So it doesn't really care. You don't need to know their password, and it will just toss whatever they have in there, including ignoring the password policy. And kind of an oddball thing here is if you're on an AD account, it won't shift your AD password to whatever you said it will. It will only shift your file vault password. If you're on a local account, it will shift all passwords and pitch your keychain in the trash. So that's always good. And of course, if you go ahead and decide to blank your file vault password, for any of you who are eager to prototype this, whatever user you do it to, you will not be able to decrypt the disk with that user from the GUI. The GUI is smart enough to realize, oh, you should have a password for this. Doesn't let you go through. I haven't bothered trying with the command line. I don't know if the command line lets you through, but just kind of FYI. So if we go a bit further, kind of look at what the errors have to say about this. You get some interesting errors when you start tracing out the console logs for this. So one of them is you get a successful verification using shadow hash. So the password is valid, but secure token is out of sync. So this kind of separates our password verification from our secure token verification, right? We also get things like password provided do not match secure token passphrase. Again, we get kind of a bit of a separation between the password verification and the secure token passphrase. So clearly, we've got a pretty good evidence that Apple's claim is correct. We are definitely wrapping the key encryption key with a password. It just so happens in 10.13 and 10.13 only, the OS doesn't happen to care what password you use. It's a fun little side effect. Of course, when you find a fun little bug like this, you have to make a tool, right? So just a little AppleScript application called SecureTokenizer. Originally, I was going to use this because we had issues on the help desk with people not properly enabling secure tokens. Ended up finding a better way to do it, so I kind of abandoned it. But put a fun little button in here, the null password button. So a nice little button to automatically blank out your passwords for people who want to have fun with that. It's actually a pretty simple little script. And really, the only key piece here is for the password value, we just have to set it to null, which I'm not a huge programmer, and I didn't realize this, but apparently that's actually significantly different than just setting it to empty quotes. The OS treats that differently for some reason. So to clarify, of course, this bug's been reported to Apple. And their general response was, oh, so you said 10.14 doesn't have this problem? Fantastic. Upgrade to 10.14 and you can fix your problem. Yeah, that's fine. Doesn't work so well in biomedical research. A lot of those scientific programs aren't particularly happy just willy-nilly going to a new OS. So let's actually take a look at what happens when you mess around with this a little bit. And we'll see if the demo will work here. So, and unfortunately, we're going to have to suffer through a couple boot ups with this. Okay, so we have two users here. We're just going to log in with this demo user, very secure password. This just shows the demo 2 does have a password right now. Wait for the thing to boot up. Okay, so let's hop out of this user and hop into the other one. This bug only works if you have at least 2 users on the box, and you can't be in the user that you're fiddling with the password on. Okay, so So we're going to do this the manual way, just to make it a little bit easier. Let's see. Can everybody sort of read that? Okay. So we're going to do sysadmin, CTL, interactive. And it doesn't really matter which command you use here, as long as it's on or off. Even if the token's already on, it doesn't really care. So we're just going to use demo2 as our target. And of course, it asks for a password, demo2, and just hit the enter key. Doesn't seem to care. So if we go ahead and reboot the box, file vault screen, we should get no password for demo2. It's only a VM computer. And for demo2, so we go ahead and punch in the, there you go. I just hit enter, no password. And so once we get back to the login screen, enter again. And so because this is a local account, of course, it changed the password everywhere. So here we just go back here. And we try the original password. Not so much. Not very happy with that. Make it blank. Goodbye password. Of course, you can always put it back. Just do the same process in reverse, and we'll go back. But this obviously not supposed to happen. Not supposed to be able to have a blank file vault password. Okay, so let's get back to the presentation. Suspend that. Okay. Video just in case the presentation died, in case the demo died on me. So, as amusing as the bug is, do we actually have to care about what Apple so far told us what SecureToken is, right? So SecureToken is wrapping the key encryption key with user's password. 10.13 even has a fun little bug, which means doesn't even care what password you use. However, since most people aren't actually manipulating file vault at this low of a level, as long as the user is able to decrypt the disk, most of us don't happen to care. I can't imagine too many of you are playing around with the wipe key or trying to decrypt the wipe key using the volume header key or anything like that. So unless you're doing those kind of things, Apple's description of what SecureToken is only really matters as far as if SecureToken messes up and you have to fix it, right? So let's get back to the missing pieces here. So let's start with Secure Access Token Key List. This is what it looks like. Obviously, it's full of dark Apple secrets, or maybe not so much. Actually, the contents of this file really don't make any difference. It really doesn't matter. As long as the OS is happy with the file, all is well. You can delete the file, comes right back. Deleting the file actually has no impact on the OS whatsoever. You can enable file vault, disable file vault, add users, whatever you want to do. The only impact is the contents do rotate, which is interesting. It's kind of like your password hash. The first couple stays the same and everything else changes. So question is obviously, how do we determine the link between this Secure Access Token Key List and SecureToken, besides just assuming it from the name? So if you go ahead and do like a disk-util APFS update preboot, this is one of the files that's synced. So hopefully Apple's not just wasting our time syncing stuff we don't need. So we've kind of two key facts here. The first is the Secure Access Token and SecureToken relation is actually shown in the code. If you disassemble the binaries, you can actually see that they are connected. But more importantly is when we damage the Secure Access Token Key List, so we create an invalid file for it, it breaks SecureToken. So a couple different things will happen when you start doing this. Either you will end up with no user getting a SecureToken ever, so you create a user, they'll never have a SecureToken, and you'll always have to manually force them into file vault, or the OS will cheat and decide I'm just going to put a secure token on the user anyways, even though I have no valid reason to do so. And this actually will happen even after you have multiple users who've logged in on the box, which is kind of odd. So secure token is what Apple claims. And of course, this secure access token Key List could just be part of the wrapping the key encryption key with the password. But if you really work hard and you really fight the OS, you can actually destroy all token holders on the box, and you are still able to force users into file vault. So the secure token piece, it doesn't really matter if you want to get somebody into file vault. So clearly we can kind of separate out even the initial process of adding a user to file vault from the secure token. So if we quickly look at that, oops, where's my cursor? So let's do, one of the nice things about Parallels is it lets you have multiple inline snapshots. Okay, so this one we only have one user in file vault. Okay, so let's tailor what we have going on here. Blow this up again. Okay, and all right, so if we do FD setup list, so we only have one user in file vault, nothing squirrely going on there. And if we look at, oops, can't spell. Let's look at like demo 1. So secure token is disabled for my one user in file vault, and we have one other user on the system, which is demo 2, and the token is also disabled for this user. So if we go ahead and say open system preferences here, yeah, it's gonna be a little bit on the small side. And we, let's see, we'll also do console. Can you guys actually read any of that, or do I need to blow it up? Blow it up? Let's do, just do display zoom.
Oh yeah, that too.
Let's see here. So, that's actually easier. I don't have to manipulate it. So scaled. Yay, hooray. Good call. Okay, so what we're going to do is minimize that out. Ooh, I've got updates, woohoo. Okay. Go away. Okay, so if we go to File Vault, unlock the dialog, and we try to enable users, not too happy. Doesn't particularly like that. So if we actually look, we got nice, wonderful errors here. So we have credentials invalid, we have failed result. So here's what we're looking for. So verifier secure token does not work to validate this particular user. So basically it's complaining that I don't have a secure token, therefore I'm not allowed to manipulate file vault. Or at least the GUI doesn't think I'm allowed to manipulate file vault. See if we can find, and then here's the other important one. So when the OS sees that it doesn't have a secure token, it will try to fix it itself, so it calls a secure token repair function. And in this case, it's unable to switch this user into a secure token holder because it doesn't have any other secure token holders to work with. However, because the OS is unhappy with me, if we add a user on this computer, it will either not give it a secure token at all, or it will just cheat and force a secure token on for this one user. So let's see which one it decides to do today. Create a user. And let's see what it thought about that. So in this case, even though it has no other secure token holders, it treats the test user as basically like the first user on the box and forces a token onto it. And this is even with an invalid secure token file, which I think, actually we'll just do it this way. So this is, yeah, so what is it? Yeah, so let's do, oh, I guess we're gonna have to, okay, so we'll just use the one on the desktop then. And we can actually, so this file, it's actually the same file that was in the slide. And basically, as you can see, all I've done is just deleted a whole bunch of contents out of it. There's nothing fancy about what you need to do to break it. Just throw some stuff away, add some stuff, doesn't really matter. So the OS, I haven't actually figured out exactly what's happening here when it cheats a secure token back onto the user. It doesn't actually cache anything else in memory. I think the OS just figures as kind of a last-ditch hope, it will just force one on there and hope for the best. So let's, come on. You're not going to let me out now? Okay. All right, so we'll suspend that. All right, so, please.
Now that that has a secure token,
Yes.
does the GUI let you go back and
Yeah.
enable the others?
Yep, you just have to use that user. As long as that user's an admin, you can go back and enable it.
Right.
About 50% of the time, it won't give you a token. It will just be empty, and you still won't have a token, so you actually have to go in and fix the file you corrupted. But the rest of the time, it just will cheat one into existence. All right, so let's talk about password sync. Returns again. So if you don't have a token, and you go ahead and change your password, the password at your EFI login will actually stay the same as whatever it was when you first set it up. So it doesn't change, kind of like when you do an out-of-band AD password change. So if we kind of look at what's going on, when you actually do a password change, it calls this ODM record verify password, which basically just checks to make sure your password is actually valid. Then it sends it through that sub 8B6E, which all it's doing is basically pre-processing the input, and then throws it into the secure token helpers verify password function. Basically what this function does is it's either going to say, oh great, you got a secure token, I'm going to go ahead and unwrap your current key encryption key and rewrap it with a new password, or in the case of not having a valid token, it will try to fix your user, and when it can't do that, it just kind of gives up and says, fine, I'll just change the password I can and leave the other one without telling you. So that's always cool. So if we kind of look at things, we can say that SecureToken is necessary for syncing a password, and I'm going to show you that. which makes sense considering it's wrapping the key encryption key. We also know that no token, oh, actually, you know what? So let's do this. Let's see, encryption key. So if you, okay, so let's roll back. So if you don't have a secure token and you change the password won't change at EFI login. So to bypass this, so assuming you're not going to fix your token, which for this presentation we're not going to, you actually have to remove the user out of File Vault and then re-add the user into File Vault doing FTD setup, add, and remove, right? So this is kind of like doing an out-of-band password change. So this kind of, again, points us all back to our passwords being, our key encryption keys being wrapped with our password as Apple's Secure Token documentation tells us. However, the initial process of getting that user into File Vault does not require the secure token. So we're kind of separating things out. So basically all the secure token is letting us do is it's letting us get around having to remove and re-add users. Unfortunately, that doesn't seem to translate out over to AD, or at least not until, I guess, what, 10.15. So we can also state that our token system clearly has got a little bit more than what Apple has told us, right? So it's not just wrapping a key. Part of the secure token system is also our password sync. It's not just we're just wrapping the key and us as admins don't really have to care about it as long as it works. So this was sort of unclear. So let's actually look at a demo because that will make it a little bit easier to see. So what we're going to do is, why will you not let me out of? There we go. There we go. And so let's go to this one. Yes, I don't care. Okay, so for this user, probably you're just left with the other one. Okay, so let's go ahead and we'll fix the display here. Okay, so let's go ahead and change our password. And okay, so we know what the old password is. We'll just change it to something else. Doesn't really matter. So password change seems to be successful. It's fine. And just to be completely safe, what we'll do is we'll just do the sudo distutl apfs update preboot. And so in the user, of course, it's a new password. And also we'll do, make sure it didn't. All right, so just make sure that didn't try to revert it on me. All right, so let's bounce the box. Okay, so let's try the new password for this user. Not so much. Try the old password. Lets us log in. And it shouldn't automatically pass us through File Vault since the passwords are now out of sync. And so it doesn't pass us through File Vault, so we use the password we use at File Vault. Not so much. New password. Back to normal. So the other thing we can do, let's do this. See if we can actually show keystrokes here. See if this works. So is that readable, sort of? Okay. We're gonna. So this is actually from. Patrick Wardle's GitHub Systemctl, which I guess he based it on. Oh, guy who made. Oh, okay, interesting. Okay, so let's actually do this. So we're gonna. We're going to just force our other user into File Vault. Oh, whoops. Might help if I is root. Yeah. What? Just add. So demo 1. Oh, you know what? Yeah. That's the other problem that happens. When you actually fudge your password like this, it isn't happy when you try to add another user to File Vault using that user because the password's out of sync. So it tries to unlock the disk with the password that you're providing, which is a valid login password, but it's not the valid encryption password. So let me quickly fix that. Okay, so now it should be, at least in theory, happier. Interesting. Okay, well, that's a demo fail right there. So then here's what we're going to do. We're going to run it the other way. So let's just bounce this real fast. Please. Yep, what you got?
The update Preboot command.
Yes.
I haven't seen you use that one yet. What is that one doing? Do you have any idea?
So it's resynchronizing your list of crypto users. So if you change what users are in File Vault, running that command will force all users to be on the Preboot screen, and it also forces the secure access token file to sync over from the disk. So that disk, that file is actually stored in that DS local node's default folder, as well as being stored in your Preboot volume as well. And so that syncs over the graphics, it syncs over the passwords, it syncs over the user list, and it syncs over that file. That's what it's doing. For this password change thing, since it's a local user, you shouldn't actually have to use it. Oopsies, and the bugs hit. Okay. So, okay, so there we go. I was going to try using snapshots to bypass these boot processes, but then it kind of looks like I'm cooking the demo. And so now the password's out of sync again. So let's fix this. So Come on. Okay. So we kind of flipped it around. So now the login password flipped over. So, and of course, if we all right. So yeah, so this thing is not going to cooperate for this. All right. So let's actually move on because this is eating up a lot of time for the purposes. So we're going to pause this because we're going to just use it again. All right, so it's sort of unclear, but hopefully kind of got the picture across. So let's talk about recovery keys. This is honestly the really interesting part of SecureToken. If you break SecureToken, and I do mean break, so kind of like what we have here, where we have no valid token holders on the disk, then no more recovery keys for you. So if you already have a recovery key, it's still fine. It will still work. Not a big deal. If you remove your recovery key for whatever reason, you'll still be fine. Nothing breaks. However, if you decide at some point that you ever want your recovery key back without a secure token, danger, Will Robinson, not going to work so well for you. So if we actually look at what happens when you create a recovery key, so if we look at the top, basically we come on down to where it says secure token set recovery. It generates a recovery key, it finds a secure token holder, and then uses that secure token holder to write the recovery key to your disk. And that last function, the APFS volume add unlock records or hints, is what's actually writing the APFS user onto the disk. Which, for those of you who don't know, in APFS, recovery keys are just users. They actually have each have their own unique UUID. In the Exhibit B, if we actually kind of look where it varies, instead, because we have no token holders, it pulls a SecureToken get recovery key. So it tries to find a token holder. When it can't find one, it will search through all the users on disk, still can't find a user. So then it will actually call a repair function and try to repair the user to see if it can still get a user on disk. If that fails, it will then proceed to go ahead and throw out. So if we look at the APFS volume get unlock records, so as it's searching through, it comes on down, the serialized binary and the basic hash apply is all part of generating the recovery key. So we come on down and it comes to, interestingly enough, a secure token set recovery, which in this case, all it's doing is it's throwing away your current recovery key and not telling you, and then just it throws an error and says, sorry, wasn't able to complete the function. And then when you go to use your recovery key in the future, unfortunately, it's not going to work for you because it's completely gone. If we, let's see, so actually, here, let's skip that and we'll do this. So I have on here, so this is the recovery key. Let's open this in preview. Ooh, nice and pixelated. Excellent. All right, so let's flip back here. Let's fix the resolution on this. Yeah, I guess it's, oh, so I guess that had to be full screen. Okay, that's fine. Oops. Let's see if this will let me fix the res now. Okay, so if we open up the terminal, okay, so let's actually get a, okay, so If we do diskutil APFS, list crypto users. Whoops, might help us specify the volume. So as you see, we have the one user, and we also have a personal recovery key user, okay? So let's go ahead and do, oh, you know what, actually, we're gonna have to fix the password so this thing won't be unhappy with me. Okay, so if we do an FDE setup, change recovery, personal, and we'll use demo 1. Error, unable to change recovery key. Okay, that's kind of what we'd expect. We don't have a token. However, if we look at list crypto users, a recovery key user seems to have gone missing, which is always super fun. And so try that again.
That's 1013, right?
It's 1013. 1014 will try to prevent you from doing this to yourself. You still can if you work really hard at it. And 1014 still ends up with corrupted secure access token Key List files, so you can end up in this situation. But 1014 does a much better job of saying, oh, this is a really stupid idea, don't do it. Yeah, yeah. So, and just to kind of go the extra mile here, so now that we've thrown away our lovely recovery user, bounce a box. Okay, let's do this. Okay, so we're gonna try. Okay, so we're gonna try our recovery key, see what it thinks. And unfortunately, there's no way to actually copy and paste this even with a VM. And this is a valid recovery key for the user, but not so much anymore. And of course, we bring the secure token back, all will be well, but just kind of an FYI, on 1013 at least, it will throw away the recovery key. But what this does tell us, however, is that our recovery key is tied to our secure access token and to our secure token. So let's pause this. So, all right. Yep, please go for it.
I think I missed a part there. How did
Which
the recovery key break because we didn't have a secure token
Correct.
anymore?
Yep, that's the only thing we changed.
So when you ran change recovery and it didn't let you change
Uh-huh.
recovery, was that the breaking happening right then, or was
So
that an
it's
indication of the breaking already happened?
Correct. So basically, in 1013, they didn't write the syntax correctly. So when you do change recovery, the first thing it does is throws away your recovery key. And then it decides, oh, whoops, I can't write a new one. Oh, well, but it doesn't tell you that. It just throws it away and says, oh, I'm sorry, I wasn't able to change anything for you. 1014, it will actually give you an error.
But prior to that,
Yes.
you could use the recovery key.
Prior to that, you could use recovery. Here, we'll just, we can revert it, and I will show you.
Okay.
Let's revert to this. Okay, so let's try this again. Okay, so if we use the same thing on the reverted version, and recovery key is valid. So break secure token, recovery key goes away. Valid secure token, you can still write recovery keys to disk. Fortunately, this is only really a big problem on 10.13. It is good to know, though, for all future releases that secure token actually is tied to your recovery key, which is why it's important to have all your users have a secure token on the box, not just a couple of them, because you want to have any user be able to write a recovery key to disk. So, as I said, a bit more to secure token. So let's kind of go through the findings. So secure token has to be enabled for File Vault to work. If you don't have it, you get all sorts of fun errors like this. The primary ones of interest here are unable to remove existing recovery key. This may be okay if you weren't expecting one. The interesting thing about that error is even if you tell File Vault not to use a recovery key, it still not very happy with you. And then the other one is this setup chain recovery key, unable to create a personal recovery key user, which is, again, back to this error. In the case of enabling File Vault, it's smart enough to realize I'm not able to write a recovery key to disk, therefore I shouldn't be allowed to enable. Unfortunately, the rest of the OS isn't so smart. So having secure token allows us to write recovery keys to disk. Not having a secure token means that rewrapping the CAC on password change fails. So because it's not able to unwrap the CAC, it just leaves it as it was, so you have to use your old password, which is why you have to either fix your token or you have to remove and re-add the user, because that initial add process doesn't require you to have a token. So secure token, actually having a secure token, depends on having a valid secure access token P list. And without one, File Vault still works, you just have a few caveats. So kind of back in the old HFS days of File Vault. So Apple, of course, is right. Secure token is partially wrapping your CAC with a password, but it's also these other things too. Apple's description kind of puts secure token well below the level that most of us admins tend to look at. However, if you understand that secure access token P list becomes corrupt, your secure tokens break, and that your recovery key is dependent on having a secure token, you kind of catch a few of the important secure token pieces that Apple seems to have left out of their documentation for us. So a couple takeaways. As I said, Apple places secure token below the level that we admins operate at. Secure token is obviously a bit more than just wrapping the key with a password. The secure access token plist file answers the question of what enables a secure token. It also solves those kind of odd issues where you end up in a situation where a user can't be added to File Vault for some reason, or you're not able to click that enable thing, or whatever. It often is because your secure access token plist is corrupt. And this even happens, surprisingly enough, in 10.14, where the file is now protected by, I believe it's SIP. So, but that will still end up becoming corrupt, especially on updates. And then finally, and most importantly, the secure token is connected to actually writing your recovery keys to disk. Without it, recovery key is not allowed to be written, and unfortunately in 10.13, doesn't give you a good error. 10.14 and everyone else will. So, any questions?
Yeah, are you familiar with a path to be able to validate the state of the secure token when File Vault's not encrypted?
You can just use this sysadmin CTL command. So it's
Like
for
sysadmin CTL secure token on?
secure token status.
So it'll say enabled, disabled as the response, but
Correct.
there's the underlying state of the secure token as well, right?
So that's your only indicator of what the state of the secure token is.
Right, so you could have it show enabled, but the secure token's invalid or not matching up properly with the user's OD password, for example. But there's not a call that you can make to be able to validate that secure token password or state.
Not specifically, no. At least not that I'm aware of.
Thank you.
Do you have any idea why the secure token that says it's enabled might not actually work, or why secure tokens that previously worked go bad?
So typically it's because that secure access token plist goes bad.
And what
Why
would
it goes
cause
bad, I have no idea.
Okay.
It just seems to. Why it will show enabled even when it's not, I am also not sure. It's kind of like the directory listing doesn't update correctly, that attribute doesn't update correctly. I'm not sure why. When it's actually putting together the demo VMs, for a long time it said both of the demo users had secure tokens even though they clearly didn't. So I'm not exactly sure how Apple's actually trying to validate that. It doesn't seem like it works completely consistently.
And the contents of that P list do get rotated, you said, on a regular basis?
Every time you delete the file, it changes.
So on a normal box that you're not deleting the file, it doesn't
It's
change?
it's static.
Okay,
Yeah,
got it.
as far as I know, the OS will not change that of its own accord.
But in the case of that file being corrupted, if I delete it, and what, reboot,
Reboot, it should be fine.
it should be fine? And then if it shows enabled, then everything else should just magically start working?
In theory,
Okay,
yeah. So you should also sync preboot after you delete the file.
okay,
But yes, in theory, the OS will regenerate a new one and all should be well.
good.
Just to clarify, that's implements in 14.2, correct?
Which?
What you said, just said about.
Yes, yep. With 10.14, you just have to go into recovery and disable SIP because that file is actually protected now.
But it's being recorded. I don't actually know if this is true with current Mac OS releases, but it definitely was true in the past. When you do Systemctl secure token status username, and it tells you that secure token status is enabled or disabled, it appeared to only be reading the value of the authentication authority attribute.
that seems to be
And
the
you could
case.
lie. You could
Yes.
manually put secure token
Yes.
in that string, and
Yep.
then that utility would say, yep, secure token is enabled, when
Yep.
it really wasn't. So I'm not sure I completely believe the output of
No.
secure token. In other words, if it's not, in other words, it may only be checking that.
Correct.
That is not necessarily accurate.
Correct.
So,
That's a
just
very valid
know
point.
that.
Yep.
Where is the secure token or secure access token P list stored?
Where is it stored?
Yeah.
So
What's the file
Secure
path?
Access Token P List is actually stored in the Preboot volume, and it's also stored in the DS Local folder as well.
Cool, thanks. On the other one for the secure token response sysadmin CTL, secure token status showing enabled, you can break secure tokens by just writing a hash to OD. Fails to update for secure token, still shows enabled, but it is now out of sync with the actual user password.
Sure. It's rather fragile, unfortunately.
How many, if any, of these bugs are still relevant in 10.14, and can we leverage them to fix users that are in a broken state, for example?
The only one that I've seen in 10.14 is the Secure Token P List, Access Token P List becoming corrupt. Other than that, I've never seen file vault, failed to change a recovery or anything like that. It's just that P List becomes corrupt, and then you end up with failures to add users, token doesn't enable, whatever. But other than that, I haven't seen anything else in 10.14.
So Simon, I wanted to share this with you as I'm programmatically creating a user post provisioning. Okay, so a lab wants this programmatically done, and it's been working okay until about 10.14.5.
Okay.
It's sysadmin control. I'll create the user, and then sysadmin control secure token on. It's a bug that creates a situation very similar to the one that you described before, where you hit a blank password.
Yep.
I haven't yet confirmed to the end
Right.
users whether that's still the case, but what we get is a user with a secure token that can't log in
Yep.
with the password at the file vault
Do you
decryption
have
stage.
smart card enabled?
Yeah, maybe.
Yes. Because interestingly, for NIH specifically, the NIH smart card auth software actually interferes with secure token creation.
Bingo.
Yep.
Okay.
So throw away our smart card software, and it'll be fine, or just run sysadmin CTL interactive secure token on, and just provide the correct password, and that will resync it.
Actually, we can go into the GUI and reset
Or
the
you can do it
password
that
and
way too.
Works, but it's because of NIH auth plugin, huh?
Typically.
Brilliant. Thank you, Simon.
Is there an advised method to kind of remediate or fix a
pile of machines that have various users in various states of enabled or disabled. Is it just upgrade to 1014? Does that seem to correct things, or?
It can, not always. Like, how many users are we talking about?
I don't know, it seems because of the reporting kind of being iffy, you know?
Yep.
We just seem to have, you know, quite a few that for some reason it's disabled, or it's disabled on, you know, every user, which is at
Right.
least a local and then some mobile users, so.
Right. For those, I would look at the P list first, and then see if your token issues go away. You'll know your token issue. You don't have any token issues if you're in an admin user and you can go into that file vault dialog and system preferences and enable users, and it works. If you don't, if you've got a broken token and you go in there, sometimes it will let you authenticate, but it won't actually let you add the user. It will claim to add the user, but then it will say error, couldn't do it for some reason. Yeah. All right. Any other questions or? Okay. Well, looks like that's about it. Thank you all for coming.